and a master's degree in engineering from UNESCO, IHE, in Delft, the Netherlands. He also played a vital role as a director in Greater Kandy Water Supply Project. We warmly welcome both of you for this session. And yes, so before we begin, I would also like to remind all of you to keep your mics muted throughout the session and make sure you can ask your questions regarding the content of the presentation in the chat box, which will then be answered during the end of the presentation. And we have also we are also recording the entire session, which will then be able for anyone who wasn't able to come today. They can definitely access it. And at the end of the webinar, a link will be provided for all of you for the e-certification registration. So make sure to fill in those details and you can receive your e-certificate. So once again, thank you all for being here and make sure to participate actively. You can ask your questions and you can definitely have meaningful conversations throughout the session. Thank you. Over to you, Mr. Jayasriwardana.
Right. Thank you, Lakshini. I hope I'm audible and clear, Lakshini.
Yes, sir, you are.
Yeah, okay. Good evening to all of you. And let me also warmly welcome you also this important seminar on planning of water supply schemes. First of all, let me thank the CEYWATER Consultants Private Limited, especially Mr. I.D.W. Diruvira, for organizing this seminar series and also taking the initiative. You are warmly welcome on that. And of course, I'm confident that this will be a very good eye-opening event for all the domestic and drinking water sector stakeholders in the country. This is a very important and timely topic. And also the contents of the presentations are given by a very experienced and professional senior engineer in the sector. Engineer PH is Sarath Gamini, and I'm sure it will benefit not only engineers but all the professionals, for example, like accountants, economists, sociologists, chemists, scientists, and mainly the academia. And I'm also sure that you will agree that this is the ideal time for this scenario, for this seminar, because the present scenario and the social, political, and economic environment of the country is vital and essential for this type of discussions to go on. So without much ado, let me call up Sarath Gamini, PH Sarath Gamini, to start the presentation on the planning water supply scheme. Lakshini has clearly outlined the ground rules and hope that you will abide by them. Sarath Gamini will have 60 minutes of presentation time to the presentation. Over to my good friend Sarath Gamini.
Yeah, thank you, Mr. Jayasriwardana, my friend. The EDD and CEYWATER, thank you very much. And a good opportunity for me also. My favorite subject on water supply planning. So in my presentation, as Jayasriwardana mentioned, I am doing this planning and strategies measures considering the crisis situation of our country. 18 trillion debts, 50 billion US dollar billion forex for loan, and trade deficit of 10 billion. So as a planners, we have to think that environment correctly pointed out by Mr. Jayasriwardana. Always keeping in my back, yes, that is the situation. But I am talking that to suit for that environment. I am trying to share with you all, according to my wish, a role of planner under this crisis situation. The subject is water supply planning. So I like to touch upon a couple of topics given here. Global situation of water resources, Sri Lankan situation, then cost of water, cost recovery, and water conservation demand management strategies. And I'm coming to what is water supply planning, how I look at it. And then sector issues and what the people want, perception. Then the important aspects of preparation of master plan and detailed planning and implementation of sub-planning process, the benefits of proper planning and very specific recommendation. Right. So next we'll start with the water resource aspects, global situation. Ample water in the earth, planet of earth. But if you consider the total volume, 100,000 units, 1 lakh units, what is available for affordable, reasonable price is 14. 14 out of 100,000. So if you are using seawater, there is no problem. But it involves 3 kilowatt hours and cost of in Sri Lankan scale 200 rupees. So we are talking about the global situation also, not so attractive. Then we come to Sri Lankan situation. Now it is what we get about 121 BCM, billion meter cubes from the rainfall average. Effective surface water is used, what is available is 50 billion cubic meters per year. Then water board, I have taken sample that 0.9 BCM is required at the moment. Time to come 2.4 BCM billion. So it looked like about 5% is sufficient to cater, but it is not so. There are some districts severe water shortage. To explain you with facts, I have taken Mahaveli River Basin. Water Board has requested 500,000, 0.5 MCEM per day from MSL Mahaveli. They have given approval only 300,000 meter cube per day. You will see the deficit. We have to find if you wanted to implement this one. Shortage of water. And Mahaveli River flows from at Peradini, it goes below 350,000 meter cube per day. So we are asking 500,000, 5 lakhs, but certain days it goes below 350,000. So this is in our country, we have a shortage. We have a shortage of water, right? Then cost of water. That, as I mentioned right from the beginning, so the present situation, we must be very much careful on investment. So where we are now, cost of water and cost recovery. From lake to or river stream up to the doorsteps. Involve low lift pumping, high lift pumping, chemical treatment, etc. But it needs a lot of capital investment, electromechanical item. So what is the cost? These are the typical structures of, you can see, first slide on left, typical intake, then treatment plant, pipelines, water tanks, then distribution and tap. So from river to tap, capital investment required 1,600 rupees per meter cube. What do you mean that? So river to tap, capital investment. If you get a loan, 12% interest within 2 years if you have to pay, cost is such that 1,600 for the investment. We need 1.5 million for a family or 2.1. So this is the capital cost. Whoever pays, that is the fact. That is the cost. So where we are, average cost recovery status. Very recently, we increased the tariff. Those days before the tariff revision, the average billing rate, total bill value divided by quantity is 80 rupees. We are charging 80 rupees. Now we expect 116 rupees time to come. But whereas our O&M cost alone is 85 rupees. So we are recovering only 30 rupees of capital. That means less than 2% we are recovering. Summary, we cannot recover the capital cost. So only 2%. Right? That means somebody should bear the costs. Somebody should bear the cost. Entire Sri Lankan people, we should bear the costs. So that is the background that I am thinking. Plus, I am inviting the attention of planners. That is the status of water sector cost recovery. Right. So this is about the background, breakdown, not required. So we'll go for the next slide. When we have a huge, cost recovery issue, investments are rare or very limited. What should we do? What should we do? Right? In planning process, proposal stage, we can propose demand management strategy. Another one, supply oriented. Generally, we have done supply oriented measures, more and more lanes and for the highways. Similarly, you can give more and more water supply. But our issue is we have short of capital. We cannot recover also. So we have to think of water conservation measures. Demand management strategies are required. So that part also in my mind when I am preparing. So 76% domestic sector. Mainly, we are supplying water to majority of the quantities goes to the domestic sector. So we have to concentrate about the domestic sector, where it goes. Can we manage? Can we apply demand management strategies? How can we help the people to come forward and assist? The issue is that at the moment we have average billing rate is so low, as I mentioned earlier. Even after revision, the consumption of 15 meter cube consumers, they are charging average 100 rupees per meter cube. Now, overall average billing is 116. Right. Then we have observed recently tariff revision. We have observed in 2021, average consumption of Sri Lankan families, all total, if we take average, is 16. With this tariff increase, it has come down to 13.95. Right. So with this latest revision, sometimes it might go down to 12. Our senior managers did. On left-hand side, right-hand side, you will see the number of consumers who are consuming below 30 cubic meter per month. Earlier, 53%. Now, 63%. Now, demand management already been enforced because of the tariff revision. But can we increase tariff alone? We may not be able to achieve because there are other issues. So we have studied, Water Board has studied where we are, why they consume so much. Below 30, 63%, then above 30, also 36%. Considerable people, amount of people. Mainly, you can see drop leakage and line leakage. In domestic sector, mainly, 9% of loss due to drop. If you compare with the average Sri Lankan consumption, and it is 9%. We have such drop leak per month, line leakage per month, so that is a huge amount, 27%. So these things are happening here. Then effect to the billing also, I just have put a slide there. That will affect to the consumers badly. They have additional 4 cubic meters or legitimate consumption. Then tariff their bill value increased from 40 to 78, 50% like that. So that is a problem, social problem. So then we have studied water board, especially they have taken steps and find out why water leakage, such leakage losses. Two major reasons: poor quality water fittings. The market, you cannot find a good quality fitting. And poor plumbing practice. Then water board has taken a lot of action in order to available the quality goods in the market. So regulatory measures are required for water equipment. So now it is being implemented. Plumber license also with CEDA and other agencies, water board is taking care of. These are the demand management strategies at the moment being implemented. So to assist the consumer to reduce further consumption, to minimize the losses. Now one can say that per capita consumption, yes, we have to reduce, definitely. Leakage, number one, then mitigating bad habits, so you know that kind of one. And most important one, I was thinking to share with you all this evening what happened to our rainwater system. We have been, using rainwater, right? But our country, we have not compulsory yet. In UK and Melbourne and Australia, it's compulsory. They have to use, they have to stop and effectively use. So as an alternative, supplementary sources. Then shallow well. Then hand pump well. So still 50%, we have to increase, say 50% or say 42%. So still we are looking for supply provisions. So we have to think of supplementary source. Then next item, I would like to share some of the things. Water saving equipment. So it's look like we have not seen in our market, but Mandara manufacturer, they say 70% of water, bathing water, could be saved. So there are water equipment available in the world market. So we have to think of those measures. One such thing is your atomization mode. Simply we can add filter screen with rotary switch. That's possible. This is a simple device. So we have to encourage demand management strategies, conservation of water. Right. So that was I right from the beginning mentioned. We should keep in mind that supply-oriented measures are limited due to various reasons, as I mentioned at the beginning. So demand management strategies also should go parallel. So that is the background. Now I am trying to go for the main stuff. What is water supply plan? So there are so many definitions. What I will say is, it's a process. Planning is a process where we need to give water, potable water, to the people, ministry, industries, various commercial institutions. And it involves a lot of action. And those water infrastructure and water resources are to be developed and maintained and provide water supply while maintaining, considering the environment, social, economical aspects. So this is the definition, so many definitions. So I have selected this. So it will have a lot of activities, list of activities. I just list out majority of them. Demand projection and served area. We have to give water. How much? What their needs? Everybody cannot afford shallow pipe-borne water. Then existing water sources, additional water resource required. Then water treatment. aspects to decide the treatment. What are the data that you require to collect? Then energy, renewable energy use, community awareness, and get their involved conservation measures, and water loss reduction, water conservation, quality and quantity, cost recovery, long-term sustainability, low-cost solution, asset management. All those things are involving in this planning process at some way. So that is the important part. Various activities, measures are to be considered for planning of water supply. Right. So where we are, water sector issues. I like to share some of the issues, and so that you can understand as a planner how we should react or how we should study these issues and overcome and give proposals. Water resources, growing demand. We have surface water, groundwater, rainwater, recumulation, and seawater also, but quite expensive. And other side, we have issue very expensive on water resource development, huge investment. But groundwater recharging, that aspects also should be considered time to come. One is the issue is growing demand we cannot meet. So we have to think about recharging, soil storage improvement. So we have to select one of these options, surface water, groundwater, rainwater. So we have a lack of water resources as well as development. We have a shortage. So that's a major issue in our country. Then lack of capital, as I explained earlier. Then poor cost recovery, 1,600, but we are recovering only 160. Then water losses due to various reasons. Water losses in the consumer premises. We have an issue with the water sharing with competent users. Legislation methods are being in process now. Less information data on water resources. We don't have quantity, quality, good quality database. One of the major issues. Then asset management. Now we have some attention, but generally it's lagging as a nation, asset management. Then that is the sector issues and background. Now I am trying to share with you important aspects of water supply master plan. As usual, number one, people need water. Where do they know? Where do they know? Served area and service level. Then per capita consumption. Few thoughts. Now those days we used to take 180 liters per head per day. We were studying in university also. Now, remember that now we are going on demand management strategies. We don't have money to design and implement an overcapacity. We are trying to monitor the consumption. So we have to use existing billing data and allow for NRW, calculate per capita consumption, institutional demand, etc. So we must have a good database. Planners should have access. Those data should be published. Then served area, as I explained earlier, everywhere we cannot give water. Service level also to be decided. Example. Now this is I am taking my project, Canino water supply project. There are hilly terrains, so we have isolated pockets where we cannot give water from reservoirs. Can give, but you need additional booster, very expensive, small families. So what are the possibilities that we could provide water supply? Think of special gravity main from adjoining reservoirs. to serve. This is an alternative to the having rural water supply scheme and pumping system and maintained by local authority. So what families are very small, they cannot maintain also. 18, 20 families, they cannot maintain. Then those things should be considered. We have to think of giving water, and if cannot, one is such alternative measures adjoining reservoir, failing which rainwater. So we have to identify the zone. This is rainwater zone, shallow well, groundwater. We should not scare. We have to tell the people, society, and this is our background. This is our proposal. And decision makers should be able to aware. We must be able to aware them. Difficult task, but as a professional, we have to do. Then item C, demand projection. Most difficult part is future demand. How do you predict? Migration trends. Effect due to water supply facilities. Now present trend, sometimes national census or electoral registered growth rate, we can get idea. Electoral registered growth. Electoral registered water, Chandanamalekana, it is updating. But difficult part is after, with the water supply facilities, what will happen? Then regional development, whether they have good statistics. This is a real issue. My suggestion is we must have a good quality database in-house. That means as an institution, water board should collect and keep it available for others. And research studies should be done, especially on effect due to water supply facilities. How much it increased? These are the things that we should study in advance. Then, any case, we have to give a figure. Rather than giving 25,361 meter cube per day. So we have to study this demand projection with various scenarios, with assumption. Low growth, high growth, migration afterwards supply. So my recommendation is, as a planners, you, with the assumption and available data, you do a prediction and record it and allow decision makers to select or we recommend it. So there is no other way. So by doing that, you will feel how important this historical data trends. Then we will come to water resource. That's also demand, then water resource. I have put it water resource inventory. I can remember when I was working in water board in 1983 and 4, one company, Nihal Rajapaksa Associates, and they prepare a water resource inventory answer. I think what is being updated. We need water resource inventory, quality and quantity data, and groundwater also. Because then if we are going to do a planning in 1 year, we cannot do. We have to have resources databases. Then quality and quantity monitoring, very essential. River stream gauging station. There are a lot of dams across various stream rivers. So why not gauging station? Irrigation department not bothered. So we have to have our own stations. Then next one, water resource already being used. When you are proposing, there are users, farmers, electricity, power generators. So sharing mechanism required. Sometimes we may have to pay compensation. We have to adjust ourselves. Then soil storage, retention, soil storage improvement, when you say water resources. Then catchment protection and participatory approach. So when you do planning, we must not consider it only hardware, software part. soil stage improvement, catchment protection, and we have to do with participatory approach. Those things we recorded and put it in our report to as evidence the planner has done their best to come for the recommendation and conclusion and recommendation. Then detail one, intake. Recently, I was asked to few comments about the intake. If you finalize the source, location of the intake, very important. We'll take this one, Mahaveli, somewhere here, we have to find. Most important part is water should be available. Dry season, rainy season, flood, dry season, whether river goes onto this side or other side. And pollution threat. Remember, most biggest polluter is solid waste dumping yard. Very unfortunate, solid waste dumping yards are located close to the reservoirs, rivers and streams. So pollution, not that simple to treat also. Sometimes they won't treat. Then industrial discharge, agrochemical pollution. All those should be considered when you are selecting location. Then if you go for the dimension and type, you have to spend little money. You have to do hydraulic analysis, physical models sometimes. We have to spend money to do a quality job. We have to do it sometimes in advance. We may not be able to complete within 1 year. Historical data, we have to collect. River meandering, changes. Intake types. I propose that some water authority should maintain type of intake inventory. Intake and when it was built and what happened now, the effects, whether it is functioning properly, lesson to be learned, things like that. We should study our intakes and identify the issues, then publish and do some research. We have to have our own technology. Then question of land and access toward future provision. That is a problem. Right. Future provision is a technical aspects. We have to consider the demand projection and economy of scale and keep the provision for intake. I am showing the Greater Kandy intake. So at that time we were planning, and once and for all we put up that civil structure. So food for thought, you all. Intake, especially consider the future expansion. Land, consider future expansion. Access road, etc. Then water treatment plant. To decide the type of treatment, you need quality variation. It's not that, couple of readings. We have to monitor it, especially high turbidity. It is frequency and duration, whether it is 5 hours or 10 hours. This comes in once a month or once in 3 months. Those quality variations are required. It's not only for 1 year. We have to study for a long. So we have to have our own database with easy to access. Then we have to have a database. So do the planning, we have to. Institute itself, we have to collect the data and store it, and it should be available. O&M aspects. Now we feel that we have technology and had to introduce high-tech. Cost of maintenance, repair maintenance, reliability, that's all. Also to be considered. Then type drawing use, it's good. We can use type drawing, but as mentioned, previous type drawings, we have to review depending on effectiveness. Then land area, we have various treatment plants, type, right? Flow sand, you can go up to the plate settlers, that chemical treatment. So area is varied. So we have to select the investment required and the land requirement. Then flood treatment I just mentioned because now EPL to be obtained. So these aspects to be considered. Always keep future provision. Right. Then transmission. Now, I think right from the beginning, and Mr. mentioned that economical aspects. So this I am trying to demonstrate one such example where the pipeline size to be decided. So often our engineers do. Some of the other participants could think of such measures are being practiced. We know when you have a certain flow, if you want to send a certain flow, we can select larger diameter pipe gradually, so friction loss is less. At the same time, capital investment is high. But capital investment comes right from the beginning. But friction loss and friction energy come later. Right. Then, sometimes if you increase the diameter double, you can save the gradient reduced by 29-30%. So that is not a linear relationship. So how do we compare with? We have to develop such tools to apply to find the best invest value for money. Right. So capital investment right from the beginning, but O&M cost will come later. So we have, developed a couple of, one. This is the pillow concept, that analytical method. Everybody know total project cost, life cycle cost, capital investment plus energy cost, present worth value. So this is a typical example of analysis method. So 20 years, you can get 30 years, and we can compare with different diameters, and you can prepare a table kind of thing with various assumption, variable. We assume cost of energy 35 rupees, right? Then interest rate 10%, then one scenario, right? So by using annuity equation, we can calculate, you will see in your laptop, N, that is quantities there. Then you have the diameter. Then on top of that, you can see the capital investment. So ultimately, what we are doing is total energy cost plus capital given for each diameter and the flow. And we can identify the lowest one. Then compare the accuracy of the data. We will do a sensitivity analysis. We are not going to give a like A-level paper answer. Put to Haridale. So we have to see that what are the information that we have collected, accuracy, sensitivity, variation, and decide yourself and recommend with reason. I think due to time limits, so I have given, yes, it's a small graph, theoretical. This is investment million for 1,000 cubic meter per day capacity, function capacity. So investment per kilometer. It's gradually decreasing from 100 millimeter diameter, 41 million to 1.5. Just to show you, larger the diameter, carrying capacity is extraordinary high. Just keep it in mind. Self, by going next diameter is not a big case. This is a table where I am trying to share with, how can we get the value for money? Do the calculation. I have used that formula, and in particular pipe diameter, and you get the friction loss gradient, velocity, energy NPV, then capital and total as last column. You get, say BC, second pipe. You have 150 total life cycle cost, say energy total 16, but diameter 114. Then in our own table, I can say this is a better one. But you have to have a good judgment. Are we going to install 100 or 150? Sensitivity analysis to be done. Whether we should go to next diameter. What is the cost of laying really? Road damages. If you go to next diameter, what will happen? This is just only 1.5 million repair. So planners should think twice. Use expansion probability. Various scenarios you must think, and finally you have to do the recommendation. So that is enough to highlight the role of plan. This is our time. People are waiting. Keep future provision, especially for transmission. Having second line in the pipeline is that's simple. And consider alternative routes. Now, when you are proposing a pipeline along a road, think about the alternative routes also. And sometimes small gaps are there, put up the road. These are the alternatives that we should consider. Rather than going on main road, try to avoid with alternatives. Some steps that we should follow, or I am trying to recommend, think independently and consider the overall economical aspects means NP guideline page 1. It is damage to the RDA, less saving forward. It's not that. Overall economic. It is not only pipeline reinstatement cost after green. It is effect to the society, traffic jam, all that. If you have data, we can calculate. So idea is think independently, consider all possible sensitive scenarios, and weigh and decide. Weigh and decide. That is planners supposed to do. For that you need data. So as a group, we have to prepare and collect and share it, required data. So we are going to the distribution system next. Various houses, various locations different. We need to have a good road map. Invest for a road map. Invest for a road map. Road map with footpath and steps. Those are very important. Otherwise, sometimes you will miss the poor people living on hilltop and by roads. They might not be able to get water. So we have to prepare. This is a sample what we prepared in Candy. So pipeline 1 kilometer may be 10 million, but per square kilometer at that time even you can prepare a 1,25,000. Why don't you invest? Road density is about sometimes 5 to 10 kilometers. You need 100 million to lay the pipeline, but you are not investing 1,50,000 for road map. So electricity board, we have the location of houses, even with addresses. Why don't you make use of those maps and data and prepare a nice maps? Easy to plan. Easy to plan. We have done it. Investment and benefits, you cannot compare. It's a huge benefit. We know where we are, but we know what we are doing. Then, with the road maps, new areas there, then existing distribution system also you can put it. Then nodal demand. We can think of demand density, meter cube per day per kilometer. Based on existing data, we can calculate, and we can consider the future trends. Then demand density may be suitable to decide the nodal flows. Or else we can think about the catchment area of trunk main. That's also one scenario. So many methods our engineers knows, and we have to develop and share with others. Still, I am telling that isolated pocket story, it is there. When you prepare a roadmap, easy to find. So, as I mentioned earlier, next reservoir or rainwater. You have to include those areas separate. Then I have given in G one item, trunk distribution line. Very often when you go distribution system, you will see that from the reservoir a little bit far away, for the high elevator. So better to introduce trunk distribution line, separate line IHGL to the end. You will realize by comparing, if you do the calculation with different options, you will realize. Then isolated fire pockets, as I mentioned, this is where next reservoir, adjoining reservoir. I have explained. This is a very useful and variable speed, of course, maybe not suitable for candy terrain. In case you have to feed it to the highest elevated point. Flat area, long distribution system. So where sometimes we can save the energy non-peak hour, peak hour. So we have to run it and see. Start with Anuradhapura. I can remember planners first started doing this one. This is another idea. Instead of having large reservoir and high pumps, think about variable speed pump station. Then next one, very interesting one. After pipeline, again we are digging for house connection. Whether it is possible to give house connection during the distribution system design stage, planning stage, keep the provision, plus or minus there. But time to come, we have to work to consider, allocate house connection, provision, and innovative system to protect that one, to avoid illegal connection. So quality pipeline practice, I put this slide there because planning stage we have to have a separate chapter, quality goods and services chapter. Recommend them for long-term sustainability and reduction of losses, etc. Because as we are coming to a very crucial situation, we are lack of capital and foreign exchange. So do it for a quality group. Right. So that is about distribution system. Then already 40 minutes gone. Right. Implementation of planning process. Now we are in implementation stage. Database, as I mentioned, information, this is required in the implementation. We have to do it in advance. As an institution, we have to prepare in advance. Stakeholder participation is a must. Then, of course, certain studies, research, one thing institution can do. So implementation modes I am talking. And you can outsource. You can do consultancy action, surveying, roadmap preparation, flow measurement and studies, and river runoff model, rainfall runoff model. Those things possible. We can do, or else we have to think of outsourcing as well. Then I have selected a topic myself, get ready in advance. I was telling you, advising you about the advance. During the planning process, we cannot do. No ad hoc projects. Get ready in advance. Collect information. Water resource inventory, I have explained. Demand centers. Why not do it? Take studies and invest some funds to prepare maps in early. And do quality quantity analysis. And get ready, establish the database. Identify potential sources. And aware the public institution to protect future sources. Roadmap with building location, already I have discussed, mentioned. CB database, BIM survey, there are certain areas, local authority maps. Those things are possible. It's available. Make use of that and prepare roadmaps. My topic is get ready in advance. Then water resources. There are various agencies, stakeholder, irrigation, Mahaveli. Agrarian service also, they are doing water resource development. They have a plan. They have a project pipeline. Those information should be collected in advance and should be available with index for the planners, right? Whether they are maybe consultant or in-house. So what is required is wherever the published reports are available, collect and invite. That's what I'm telling, data information sharing. We can buy it, still work. And we can share it our works and create a culture, sharing of information, willingness to provide, share our data. We do flow measurements and give the data to others, and quality, quantity, others. Then last item on this action, cost of raw water in O&M budget. When you do planning, we think that, it's the proposal, no? Hardware. No. Always, it is in our guidelines also. We have to include our O&M budget, all possible risk factors and implications. Now, time to come, raw water costs might come. So why don't you add? If raw water costs to pay, then this much of money required. What is wrong with it? Just write down and estimate, then give the cost. By writing, that we are not going to give the total amount, that depending on the appropriate process now already initiated, but it should be budgeted and identified. Compensation events. Right. Then I have put a topic as identify potential water sources. Now, when you do this planning work with roadmap and all, demand centers are identified, then amount is, and we have to identify potential sources. Then most difficult part is negotiate with the users and formulate agreement. We have to do it very in advance. This is not the after, signing of the loan agreement, we may not be able to do. And when you start, sometimes we may not be able to get the intake. Others we can do. So better water resources, yes, we have a mechanism, compensation, negotiation mechanism, so we might be able to do it in future. Then I am just suggesting, always land is a problem. Land required for the water infrastructure. As we have potential water source and we have demand centers and identify treatment location and reservoir and try to reserve. Lot of advantage. And people also very happy. Even politician will happy. Yeah? Reserved for treatment plant future. Tanks. Whether it's come or not, at least start with Land Reform Commission, Railway, JDB, Mahavali, some temple lands. So we might miss such good location and finally end up with a very expensive and land development. And you need, alternative land development and access road, etc. So best location, you could reserve it. Then I have mentioned demand centers, served area to be identified, consultation with stakeholders. Now we have a department called National Physical Plan. They have prepared. Then district level we have. In time to come, division secretary level also they have plan. Provincial level, infrastructure plans. All those things to be collected and inventories should be available or to make use of for our planners, private sector or our own in-house. Then again, I am mentioning rainwater harvesting, stones, groundwater usage. We should not kill rainwater system. This has been, there. And we have to promote now high time. And groundwater usage and improve the groundwater storage. Now we have shallow well improvement. Demand strategy should be implemented. So I have put that, last two items, general public awareness, that is very important. Role of citizens on water sector issues and management. And university colleagues, university students and university academics, technical college students and their lecturers, they all should know, especially politicians also. We should tell them about the water supply planning, how expensive. We have issues, sector issues, cost recovery issues. We have to make awareness. That's a must. Whole problem is we are trying to hide things which should be published. It should be published. Then regulatory measures I have already touched. Important measures to be implemented and should be included in our planning process. Then if you have done good planning, benefit, site benefit, roadmaps available. Other sectors also could utilize. We can prove that we have planned very well. This is rainwater area, this is shallow well area, this is where we can give water. These are the phasing out, so this will be implemented in 2030. So we can market our proposal and explain to others why we cannot do. Then integrated approach, complying with legislative. We have archaeological clearance, CA clearance. Then water issues to be resolved. Those things are very important because it's a part of our legislation. So especially public sector projects, we have to comply with. It's a kind of demonstration through our planning report that we have already taken action. Then I am trying to highlight overall economical aspects. This is 2006 procurement guideline. Even 2017 procurement guideline, it is mentioned. It is there. Overall economical aspects. More often people, our professionals, administrators think that overall economical efficiency could be obtained after preparation and submission of bid document to the tender board. It is impossible. Halfway gone. Unfortunately, in this guideline, it was mentioned about something about EIA and land acquisition, but they have not mentioned about the project proposal preparation. Too much attention is not given. So because of that, all right. So we are trying to discuss it in time to come, maybe next session, but relevant for this one. Overall economical aspect to be considered. So it has to be started at the day one, where we are going to do identification report, preliminary master plan, pre-feasibility stage. Otherwise, we may not be able to give value for money at maximizing economy, right? So this is very nicely written. Even World Bank, if you go, overall economical aspects. ADB, yes, overall economical aspects. But we need adjunction. We have to give due weightage for this one. Not because of in the NPA or World Bank. Now we have gone to a level. Now we are surviving with all difficulties. So now itself think about what is economic cost, what is economic evaluation, how we can achieve, how we can give value for money. Right. So that is important factor. That is what I put aside also. Overall economical should be considered. Social aspects are considered. Now we have, if you have a good plan, then reasonable level social impact to farmers, landowners, less impact. Especially land acquisition. Each and every projects, we must give an involuntary resettlement plan. We should give. That's a part of law. And we must include in our reports. Then after the reports, we should not keep it in our own library or in our shelves. It should be shared with others. Then only they will share with us and useful for national planning and others. Then I have put phasing out possible. This is very important. Phasing out. We cannot give average all. Consider the difficulties and the available funds. Phasing out program. Phase out, very important. Think about during the planning stage. Stage 1, stage 2, stage 3. But certain structures like intake and that can be final capacity. So this is where everything in planner's hand, right? Now 53 minutes. Okay, 7 minutes more. So I have given, trying to share very specific recommendation. I have discussed. I am telling I have explained a lot of things, but I need to concentrate one thing. Database. In the advance, we have to prepare, and we have to share it. We have to get it from others also, and with index, and should be available for the whole entire nation. No harm for planners, various decision makers, administrators. Why not? For auditors, everybody. National investment. So why don't you share that investments and reports? So consult everybody. And I am telling, requesting, appealing, inventory of studies. How much of we have prepared the feasibility report, design report, then we have the O&M manual, as-built drawings. Those things should be available. Otherwise, very difficult for do further planning, and sometimes operation maintenance also difficult. So habit of collecting information and inventorize and storage, not like earlier days. Now we have a lot of facilities which we have started in central RSC, and now we have started recording. We have done for about 8 lakhs drawings and a couple of reports also. So those things, especially maps, we need that 20 years, 30 years back, maps were saved and stored. So effective database required, my dear friends. Then research and studies. There are a lot of students, they are asking various projects. I think we have some research topic, inventory also. So incentive for planners, even allocating certain money, funds to promote research studies, which are very vital, important for the benefits of the planners and future prediction, and identify the trends. So we have to invest for research and studies. Innovative treatment. At least if you have an intake, if you study 30 intakes and identify the plus and minus, good and bad, and what will happen during flood season, rainy season, and drought season, very good information. Should be shared. Those are research studies. Then 56 minutes, change ourselves. This is very important. Now we have been practiced for years and decades certain way. Now we have to change. We have to think about our economy. Now we have to invest very carefully. We have to find the best way to invest, value for money, economical aspects, and sharing with others, and do some studies ourselves and predict reasonable accuracy and give impact to the people. Impact to the people. Change ourselves. Then, as I mentioned, so many occasions, consider overall economical aspects. Not because of NPA guideline, that is a part of our role. As a planners, decision makers, administrators, we should do value for money, considering overall economical aspects. So my friend, 57 minutes. So conclusion, on your left-hand side, it represents the part of Sri Lanka, the water supply situation. And our goal on your right-hand side. Planning is a process, lot of big activities, including change of ourselves, and way forward to achieve this target one day. Gradual process. So that is what I shared with you with last 58 minutes. So Edri, thank you, Mr. Jayasrivardhana. So I have finished this task. Head of schedule, I am supposed to finish it in 60 minutes. So I have done it. Over to you, MC.
Thank you, Engineer P.S. Sarath Gamini. He has demonstrated how to even plan a presentation to complete on time. Very good. And so thank you very much for very enthusiastic, detailed, and very timed presentation. I don't want to repeat what you say or make a summary. It will be very clear and very precise. So I think I will open this time for the questions, the question and answer sessions in Sarath Gamini. I will read out the questions at least that come on the chat box. You are ready, Mr. Sarath Gamini, right?
Yes, I'm
Okay.
ready. Yeah.
So the first question is from Mr. Jayant. It has two parts. I will read out the first part. Will you be incorporating provisions for climate change impacts like extreme droughts and floods in planning? Is the question clear?
Yeah. Yes. May I address? Yes. Now I have mentioned that establishing database and if identify the effect and trends, depletion of water, and we have to identify the remedial measures. Example, recharging, improving of groundwater storage. It's sure, as you say, it is correct. Then floods, of course, water supply planning, what we can do is protect ourselves. When I discuss about the intake and treatment plan, predict the flood water level and minimize the risk. Maybe elevation. Other one is especially for pipeline where we are crossing the rivers, especially pipe bridges. And of course, my worry is change of quality during the flood season and due to bad with the land's preparation improvements, the ability goes 800, 900 sometimes. So it is a part of that.
Right.
Yes, agreed. Yes, it should be there. I have just not just mentioned also, instead of putting the word climate change, I have covered that aspects also. This is part of planning.
Right. Thank you, Mr. Sarath. Then the second part of Jayant's question is, have you integrated measures to control carbon emissions into water scheme planning process? So, yeah, please.
Yeah. Now, I have mentioned how do you minimize? That is, now, even though we are getting the energy from DB, somewhere they produce carbon. So what is required is, as we have a huge area, land area, better to make use of at least solar ponds. And we have a couple of reservoirs, floating solar ponds, and at least solar energy could be utilized. Maybe wind energy, we have to do study and find out, whether it's a suitable location. There are agencies, they have identified the location. Definitely solar power would be used in our treatment plant. There are advantages also. And color to our large reservoirs, our own reservoirs, it is possible. Just that aspects to be considered. I have mentioned renewable energy to be used during the master plan preparation process. Yes.
Thank you, Mr. With your permission, I can add. Now you mentioned about the recycle, reuse, and reduce. That's also part of the same issue. And of course, we are also talking about the water footprint. So these are also measures that we are taking, I'm sure. Right. Thank you. Then we can move on to the next question. That is from Tarika Fernando. The question is, how do you calculate the capital cost per cubic meter water delivered? What is the lifetime you have assumed?
Okay. I will share with the slide. Capital cost, I have given one scenario. Assuming the 20-year life cycle and loan is also 20 years repayment, and just to demonstrate the cost ranges for the planners. Imagine it is 1,600. If you go to detail 40 years, generally structures, transition main, sometimes we have more than 100-year-olds also, effectiveness. So our O&M structures, 60 years, and say, for example, transition mains, maybe 50, 60 years. So I have done this, taken the example for 20 years, just to demonstrate how expensive it is. Now, for example, with different interest rate, I can share it. Possible? Right. So different interest rate, just show me the table. Right. So I have the table, say 8%. We can say if you have 40 years, so 1,000. If you have a 20%, if you can loan is available only 20% for 40 years, even 2,300. So 20 years, 2,500. So we can do calculation and show it to the planner, the decision makers. This is the real cost of water. Is that your question? We can, depending on the lifetime, different, say, pumping lane, yes, 50 years you can put it. Yeah.
Yes, I think you are clear. Thank you.
Yeah.
So let's move to the next question by Mr. Daya Gamage, I think our good friend. He says, I propose appropriate automation, smart metering, and remote reading possibilities of water meters and meter reading without conventional meter readers can be suggested for cheaper water production. So this is mainly a sort of proposal. And I hope you will comment on the Mr. Gamini.
Yeah. Now, also, investment and benefit, or all economical aspects. And now, smart meters may be suitable for large, vulnerable customers. Small scale means we have about 2.7 million customers, investment and benefit. Even if you get the reading at, within every week, so what you are going to do with that reading? What is the prediction? Is it worth? But there are large consumers worth to monitor, whether they have illegal tapping and all. So smart metering, investment and benefits to be analyzed. Better to start with that already a pilot project and see.
Yes, I think I just want to add, Mr. Gamini, probably automation part to increase the reliability of the process, supporting the treatment process operators. Maybe those are also things I'm sure we can help, right? Yeah. Then the next question is by Mr. Balasubramaniam. He asking, allocate quantity of water per family according to number of members in the family is better in future. Right. So it's a tough question.
Yeah. Now, at the moment, metered consumption is used.
Yes.
Then depending on the number of family increase, number of person increase, and of course consumption also increase, and they are moving on the ladder, higher steps. So in future, if the tariff structure is drastically changing, we may have to allocate per capita consumption, per capita allocation, per person kind of one. Otherwise, it's not fair for such families with 10, 12 members. Exactly. Yes, the food for thought. Yeah.
Yes. Thank you. Thank you. That's a good answer, I'm sure. Question. Yeah. Then moving to the next question. Mr. Intujan. How to determine pipe materials such as PVC, PE, DI? He's asking what are the factors to decide the pipe materials, PVC, PE and DI. What do you consider?
Yes, very general question. PVC pipes, now according to research in Europe, it's outdated. Now they are replacing. In Sri Lanka also, time to come, we may have to replace. And we have pressure classes and impact to the change of search and other things, plus lifetime. And there are advantages, PVC jointing, then with rubbering, then as it gives problem because of the mold and other things, lead effects, we are trying to replace. So now PE pipes come. One advantage is we have a solid joint. And there are also, we have an issue on the vacuum. Low pressure means below contraction. So not like ductile line pipe. So, but still with pressure control up to 12, 16 PE pipes are being used. Ductile line, terrain, considering the terrain, impacts, that means pressure changes, surge, and up to 25, even beyond that, we will use steel. So the user requirement, we can decide the type of pipe and pipe type. More important, PVC pipes are manufactured in Sri Lanka. We have to promote our industry also. Now, PE pipes also manufactured in Sri Lanka. DI pipes are coming from completely from imports. All those things should be considered in time to come on selecting. Not only quality, economical benefits also to be considered. But in any case, technical requirement to be satisfied.
Yes, thank you. Then Mr. Intu has a second question also. How to determine ground reservoir high elevated tank used for storage? I mean, how do you decide on whether it's a tank or a reservoir? That's what I think this question is.
It's a tower or tank. Is that the
Yes.
question? All right.
Exactly.
Yeah. So when you identify the roadmap with distribution system, and we have to decide hypothetical locations, elevations, and the pressure and the economical sizes of the or total distribution cost. We don't want to bring it to very high elevation and pump it and bring it, whereas we need high elevated pockets, maybe 5% less. So we have to evaluate and see. Then tower and reservoir, that depending on mainly the location. If we can have a ground reservoir, if we can achieve the elevation, that's why I suggested, nice locations are there, we have to reserve it. In advance. Otherwise, we have to put up a tower. In Colombo area, we have to put up towers.
And also, Mr. Sarangam, you mentioned that now we are going for inline boosting system without towers also. That's also other.
That is still we have to, in time to come, we have to think about
variable speed.
Variable speed pumps. With power supply improvement and the reliability also matter.
Right. Okay, let's move down. LC Yasudasan is asking, our LC, please share on surge-related design precautions, etc. Surge-related design and precautions. I mean, it's a new subject, but can just mention the need for surge and all the Mr. Gamini, how we.
Yes. Those days, very thumb rules were there. Now, of course, there are packages. There are experts. Surge analysis. So, is that your requirement is to facilitate to provide some surge calculation methods, or is that your question?
No, I mean, she's asking a general question. How we can, I mean, the planning aspects of the precautions using surge and all that. It's a general question.
All right. Okay. Now, when you decide the surge, first we have to have a profile. LS. That is a part of that for surge analysis. The planning stage, if we have a thumb rule, similar situation, before we go to the detail, we allowing certain static pressure and working pressure, and we allow certain percentage, say 60% for the surge, and decide the diameter. And later, we can do a detailed analysis, and most importantly, not only high pressure, and column separation and vacuum also formation. So special precautions to be taken, maybe 1 or 2 double valves, air valves also. Otherwise, fractures are possible, especially PE pipe. So what is required is to, if you have a real profile, that's what we want to, if this is a critical one, our judgment is do the profile, LS, and find out how sensitive it is. Whether to go for 16 PE, P25. Invest some critical stage. My advice is invest. That is also part of judgment of the planner. Invest and do the LS and go for a package and find out.
And also, as you said, you have to look at the total cost of pipeline cost and all that together, and before the mediation, right? Thank you. Now we have a tough question from Mr. Dinesh from Sarath Gamini. It says, how can you improve the coordination among different utility organizations when we plan to lay new pipelines? Is it possible to allocate space for utilities on the road for future expansions? Otherwise, we have to damage newly overlaid roads continuously. I know it's a tough question. We are talking about it all the time, but I'm sure you have a way forward. Yeah.
Yeah. When you do master plan, reserve trunk mains, key distribution early as possible. One of the outcome is, I say, always share it for others. At least we are laying pipeline in 2030. That is to at least to avoid immediate carpeting.
Yes.
Then corridor. That of course acquisition of land and how much, 10 feet or 20. And then allocate among the other users. Cable car, cables.
Yeah.
And power cable and etc. So utility corridor, it's it's kind of hypothetical idea in a way, but we don't have money to acquire and to overcome the resistance of the general public to have a corridor. But in near future, if you are designing a new roads, yes, we have to find out whether it is worth still. That is also important.
Yes.
Acquisition of land from the people and maintaining that road. That is also important. Then that's what I slightly mentioned. Find alternative road. Rather than going on A series, try to find. I did I saved 2 kilometers of Kadukasar to Kurunagala road.
Exactly.
I have to do about 450 meters of road, new road. That is plan should do decide. Try to avoid, minimize it. But in Sri Lanka, the investments are coming in haphazard manner. Yes. Roads investments come first. We don't know. And water supply will come depending on the national level program. So that is there. It will be there for another couple of decades unless we complete all our plans. Road master plan and this one, and have a real steering committee, dynamic, sincere people to manage.
Yes.
Then we can save a little bit.
Yeah. And also in addition, we have to plan for wastewater also in the future. Storage. Yeah.
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 Utilities,
So,
yes.
Yeah. I think I can take up one more question due to time limitation. The name is not there. It says, Dear Gamini, have you given any consideration to do raw water catchment analysis to exclude cryptosporidium risk in water treatment? A specific question. Cryptosporidium risk in the water treatment process. So, I mean, yeah, but I don't know whether we have any experience of this.
I don't have that experience. In that kind of situation, that is also very important. When there's a real problem, there are expertise within the board.
Yeah.
We have to consult them. Yeah. And whether there are such problem in future or at the moment reported.
Yeah.
Now people say algae, a lot of problems are there. But whether there are such threat in existing rivers and cyanide pollution, but not yet reported, even agrochemical.
Yes.
I used to ask on Dr. Veragoda and others whether there are such situations. So similarly, these particular issues, if it is come, we have to consult the relevant expert. Yes. So planners should know where to go out and outsource. Exactly. That's the important part.
And I think also in addition, Mr. Gamini, as you said, it also said that you need to have a good water quality analysis covering one wet season or 1 or 2 dry seasons. So, I mean, you mentioned that. So it's the importance of having a good water quality database. I mean, that's what it all amounts. I mean, crypto is only one, but then to identify what is there, you need to cover at least 1 or 2 wet seasons, 1 or 2 dry seasons to capture the whole picture of the water quality scenario, right?
Well, that is correct. We have to invest to identify the real quality and quality changes.
Exactly.
Trends.
Yeah.
It is worth to do studies at least couple of rivers and dams so that we can do analogs at least with others. So that is the point, as you mentioned, it is the need of database and changes and monitoring of changes and making decisions and recommendations to the management and investment required to rectify.
Yes. And also, I just want to add that with my experience on climate change, the climate change also changes the temperature sometimes. And this playing havoc sometimes change temperature. So even 1 or 2 degrees increase in temperature makes a big changes in the process and all that. So, okay. So I think we have only time for all that. So thank you very much for all the Sarath for asking questions and answering, and the listeners. So there are a lot of questions. There are about 65 questions. So what we agreed was that we will go through them and then come back to you. We have a database of your emails. So we are so sorry that we couldn't answer each and every question to blind invitations. Thank you very much. And I'll hand over to Lakshini. Lakshini, please. Lakshini, over to you.
Hello, Mr. Sajan, am I audible?
Yeah, sure.
Yes.
Yeah. Okay, Mr. Sajan, Mr. Sarath Gamini, thank you very much for the most resourceful webinar and the information that you have shared with us. It's a very descriptive and comprehensive explanation and description about water supply planning. So thank you very much, Mr. Sarath Gamini, for the effort and the dedication taken into the in delivering this fruitful webinar. And thank you very much, Mr. Sajan, for your amazing moderation. At the same time, I would like to thank CEYWATER team, Mr. Vijay Dirivira, Mr. Rakmal Betmage, Mr. Veerasiri Apegunawardana, Ms. Vimalsha Maheshi, Ms. Lakshini Ferdinandez for planning and arranging this webinar. So just to give you a thought about our intention on this webinar is that CEYWATER is looking forward to create an online collaboration platform where multidisciplinary experts can come together and share their knowledge and experience. I think that's one of the very needed requirement in the country in terms of sustainable development. So we would like to keep this effort very continuously delivering this as a series of webinars. So I would like to especially thank the participants who participated in this webinar, who have shown their keen interest in the knowledge sharing and the experience sharing process. And it's a very, I'm very pleased to see such a great number of participants. And just to mention that we have shared a link in the chat box where you can register your name and also leave your feedback. Of course, we will use that particular name to issue you a participation certificate. And just to highlight, our next webinar will be planned the next month, September 6th, and we hope to conduct that particular webinar on the aspects of procurement of quality goods and service for our nation, especially understanding the procurement process. So you can leave your feedback, the feedback link that we have given. So we are always trying to create more fruitful and more meaningful topics for our discussions, and to keep this effort ongoing. The support we received from the participant is the most important thing. So thank you very much, everyone who participated in the webinar and who contributed for this webinar in many ways to make this a success. So thank you, everyone. Lakshini, if you want to add any final comments, I would leave it to you.
I'm sorry, I didn't catch that.
Yeah, I think so. We have reached to the end of the webinar. If you want to add anything, any final comments before the closure, maybe Lakshini or Sarath Gamini. Sajjan?
Yes, actually, on behalf of the entire CEYWATER team, again, I would also like to thank Mr. Engineer CEYWATER and Engineer Sarath Gamini for doing this with us. It was genuinely an amazing insight for the whole topic. Thank you so much. Hoping to see all of you all the participants next time around 2.
Great. Okay, ladies and gentlemen, thank you very much. And we wish you a good night.